Hey guys, today is our third lesson in Unit 9, and today we are talking about factoring sum and difference of cubes. We're also talking about perfect squares and stuff like that, but the thing that we're learning that's new is this idea that we can take perfect cubes like this. If you have something cubed minus something cubed, we can factor it. Or if I have something cubed and we're adding, we can factor it like this. The important part is whenever we factor these that we use what's called SOAP. And it's going to be same sign, opposite sign, and then always positive. So if you'll notice we have a negative here. Whenever we factor it out, this is the same sign, this is opposite sign, and this last one's going to be always positive. Same thing here, if I have a positive, this is going to be the same, it's going to be opposite, and it's going to be always positive. Now, you'll notice we also have difference of squareds here. Now this difference of squares, we've already known how to do this. We're just going to practice it a bit more. We're going to start with difference of squares, and on the second page we're going to do some sum and difference of cubes. So let's go ahead, let's go down here. Let's take a look at number 1. So number 1, we have this factoring problem, and let's first talk about what is the first step in factoring. The first thing that we always have to do in factoring is look for a GCF. So I'm just going to write GCF, or greatest common factor. Okay, that's our first step. That's always our first step when looking for the factors of a polynomial. So kind of what we're doing is we're doing the opposite of multiplying out. We are factoring, we are creating those parentheses. So number 1, well, first let's investigate. Let's see, do we think this is a difference of squared or a difference of cubes problem? Well, this one has a squared, so I'm going to think difference of squares. Now, whenever we look at this, we're going to think, okay, what are these as perfect squares? Well, x squared, that is x squared, okay? And 49, that is, well, if we take the square root of 49, we get 7. So 49 is 7 squared. Remember what our formula is, okay? Our formula is a squared minus b squared equals, okay, so once we find what a and b are, we can just write our formula. And our formula is a plus b times a minus b. So in this particular case, my a is x, and my b is 7, okay? So I can just kind of plug this into this formula, okay? So we can just go, okay, my answer is going to be x plus 7 times x minus 7. So the first thing is we just have to figure out, okay, what are these simplified down? What are these actually, after we are no longer squaring them, after we square root them, what are they? And then we just plug them into our formula, and hey, that's our answer, okay? So the same thing works for all the formulas, for the cubes, for everything. We just figure out, okay, where does this go? What is this? What is A? What is B? And then we find it out. Okay, so number 2, similar idea. We have a 16x to the 4th minus 81. So first step, we're going to define what A and B is. So, or A and B are. So in this case, check it out. We're going to square root both these. And the square root of 16 is 4. And the square root of x to the 4th is x squared. So we're going to have 4x squared squared minus what times itself equals 81? 9. So this one's going to be 9 squared. Okay? So this is my a and my b. So my a is 4x squared, and my b is 9. So we can write out my equation. Remember, it's a plus b times a minus b. On top here, you might have noticed that it's a minus b, a plus b. It doesn't matter which way you write it, if you write it plus or minus first. Okay, so we're going to write this out. Oops, I hate it when it does that. Come on, there we go. Okay, try that again. So we're going to write out 4x squared minus 9, or plus 9, times 4x squared minus 9. Perfect. Okay, but everybody pause for a second. I want you to think, could we factor this again if we needed to? Well, 4x squared plus 9, I can't factor that again. It is a sum, and there's no cubes. But take a look at this next one, 4x squared minus 9. Maybe I can factor that one again. 4x squared is a perfect square, right? We could rewrite this as 2x squared minus 9 is a perfect square too. We could rewrite that as 3 squared. So once again, I have a difference of squareds. I am minusing my squared. So I can write out this as 2x plus 3 times 2x minus 3. That's what this equals. However, we still have this parentheses out in front, 4x squared plus 9. This can't factor anymore, so this whole thing is just going to be my factor out answer. Sometimes, if we're lucky, can factor out twice. Okay? So if you ever see x to the fourth, you might be thinking, oh, maybe this one will factor out twice. Okay? Sometimes it does, sometimes it doesn't. Let's take a look at number 3. So number 3, oh, I need to remember my first step, and my first step is this has a GCF. And this one has a GCF of 3, right? They have a 3 in common, so I can divide both of these by 3 to get us started. So we have 3 times x to the fourth minus x to the fourth. Okay, x to the fourth and x to the fourth are both perfect squares, right? This is the same thing as saying x squared minus x squared, y squared squared. So we can write this out instead. If my a is x squared and my b is y squared, I can write this out 3 times x squared plus y squared times x squared minus y squared. But then we need to check again and see if I can factor it again. And this x squared minus y squared, that is a perfect square. Let me write this back up over here. So I'm going to write over here 3 times x squared plus y squared times x squared minus y squared. Now, x squared minus y squared is a perfect square. So I can write this, the square root of the first one plus the square root of the second one. So the square root of the first one is x plus the square root of the second one, which is y, times those same two things minus. You see how on this particular problem, we got a new a and b. My new a was x, because x squared divided by, x square root of x squared is x, and my b was y, and that's where I got my new thing. Right, what's in front, back in front, 3 times x squared plus y squared, and there you go. There is our factored out solution. So sometimes, whenever we're doing difference of squares, it can do it again. So it happens. All right. Okay, let's turn the page. And I want to remind you, these are the formulas for difference of cubes. So if we are minusing, we go same, opposite, always positive. So my first one is the same, middle one, second one is opposite, last one is always positive. If it's positive, it's going to be the first one's positive, middle one's opposite, the last one's always positive. Okay, now, these first two are just whatever a and b minus or plus each other. Then we go that one squared, and then the two multiply together, and then our last one squared. So let's start off with number 4 here. Number 4, we have x cubed. Hey, that's pretty simple. If we're looking for cubes, well, we can just pull that out. That's x cubed. Okay, minus, okay, I don't really, well, I do, but you might not really know the cube root of 125 off the top of your head. So pull up your calculator, and the cube root of 125, remember, just think, what times itself 3 times equals 125? Well, 5 times 5 times 5 equals 125. So that's going to be 5 cubed. So that means that my a is x and my b is 5. And this one is a minus So we're going to be using this formula right here. So let's fill it into this formula. The formula states that we go a minus b times a squared plus ab plus b squared. So we know what my a is, we know what my b is, so we literally just plug these in, okay? So if we go, my a is x, so we'll go x minus my b is 5, so x minus 5, x squared, my a, and then plus x a times b, so that's x times 5 or 5x. And then lastly, b squared, well b squared, that's 5 squared is 25. So there is my factored out solution. Okay? All right, we just have a couple more. Say, look here at number 5. So number 5, we have a, first off, we look for a GCF, right? In this case, we have a GCF. My GCF, well, we have y squared in common, but I'm also going to have a 2 in common, okay? So we're going to need to pull out a 2y squared from each one of these. So we're going to get 2y squared in front times 8y to the third plus 27y squared. Okay, the cube root of 8 is 2, so we can write this as 2y cubed plus cube root of 27 is 3. So this is going to be 3. Oops, sorry guys. This y should have gone away whenever we divided, right? Some of you were probably yelling at your screen for me. Look, 54y squared divided by 2y squared is just 27. So this one's just going to be 3 cubed. Okay, so now I can see what my a and my b are. So my a is going to be 2y. My b is going to be 3. Can't forget this 2y in front, and then we're going to go through the motions. This one's a plus. So let's remind us what our formula is. It's going to be a plus b times a squared minus ab plus b squared. So if my first one's a plus b, we're going to go 2y plus 3, 2y squared plus 3 times 4y squared. We plug this in and square it. So the square of 2 is 4, and then that's y squared, minus, because it's opposite, these two multiply together. 3 times 2 is 6, so 6y plus my last one squared, which is 9. So there is my answer for our second cube root problem. Now let's try number 6. Look at this. Number 6, we already have something out in front. Well, I can't factor that anymore, so we're just going to ignore it and we're going to leave it out in front. However, we also have this x cubed minus 27, and I can do something with that. We're going to take that, leave this x minus 2 out in front, and this x cubed minus 27, remember that's x cubed minus 3 cubed, like that. And so that means my a is x and my b is 3. We're going to just plug this into my formula. So it's going to be x minus 2 times x minus 3. So remember, same on the first one. So x minus 3. A is x, b is 3, times x squared plus 3x, because it's opposite in the center, plus 3x, because we times the 2 together, plus 9, because it's always positive at the end, and 3 squared is 9. So my b squared equals 9, and then this is my factored out portion. All right, our very last problem here, number 7. Number 7, factor completely this. So first off, look for a GCF. In this case, my GCF equals 4x. So we're going to divide both of these by 4x, and we're going to get 4x times 9x to the fourth minus 1. Okay, let's see. Well, 9x to the fourth minus 1, that is not a cube. It's not a cube, we see a fourth. And so we can say that this is probably going to be a squared problem. So I can break this down. This 9x to the fourth minus 1, well, that's going to be 3x squared. Let's write that better. That's going to be 3x squared minus 1 squared. 1 is like the perfect square cube. You can multiply it by itself however much you want. It's still going to equal 1. Okay, so that means that my A equals 3x squared and my B equals 1. So whenever we write this out, can't forget the 4x in front. We're going to go 4x times 3x squared plus 1 times 3x squared minus 1. Okay, let's see if we can factor this again. This 3x squared minus 1, well, it's very close to being able to factor. 1 is a perfect square, x squared is a perfect square, and we're subtracting, but 3 is not a perfect square. So I actually can't factor this anymore, and this is simply going to be my answer. Okay, that's it. Factored out. And how do you know when a polynomial is factored completely? Well, you know whenever there is no more factorial parts, no more parentheses that can be factored anymore. So you check and see, does it fit the criteria? Is everything a perfect square and we're subtracting, or is everything a perfect cube? And if they are, then maybe we can still factor. So check and see as you go, can I still factor this? All right? Okay, well, that's it for this lesson. I hope this has been helpful to you. Hope you have a great rest of your day. Thanks, guys.